Okay, here's our bell assignment for today. Go ahead and work on this at your seat and put your answers up on the board whenever you are done at your seat, and then you can go over them as a class. Please pause this so that it doesn't go to the next slide. What we're talking about today is lesson 63, rational numbers, non-terminating decimals, and percents and fractions with negative exponents. Okay, it says recall that every Recall that every rational number can be expressed as a ratio of two integers. Converting the ratio to a decimal number results in a decimal that terminates, which means that it ends, or it does not terminate but has repeating decimals. Okay? So, once again, converting the ratio to a decimal number results in a decimal that either terminates, if it terminates, it ends. Okay? Or it does not terminate but has a repeating decimal. And that is if it is a rational number. Those are the two types of rational numbers that you can have whenever you're talking about ratios. It either ends like 1/4. Okay, 1/4 we all know is 0.25. Or it repeats like 1/3, which we all know is 0.3 repeating. It's numbers like pi that go on and on and on and on and no pattern. Those are irrational. So what we're talking about are either terminating decimals or repeating decimals. So they gave us an example of 1/8 equals 0.125. Okay, that terminates. It ends at 0.125. It does not continue. Non-terminating but repeating, we have 1/11. If you punch into your calculator 1 divided by 11, you're going to get 0.09090909. It goes on and on and on. So we know that whenever we have digits that repeat, we write it with a repeating bar. Okay? And the repeating bar only goes over what's being repeated. So we are repeating 0.9 here, so we put a bar over 0.9. So our answer for 1/11 as a decimal would be 0.09 with the 0.9 repeating. And 0.9 would be considered our repetant because it's what repeats. We do not perform computations with a decimal number that has a bar over the repetant. Instead, we use the fraction equivalent, or we round the decimal number to the appropriate number of decimals. And we don't do that because we want to have an exact answer. And if we have it repeating, we don't really know how to punch that into our calculator, okay? So you can't punch in 0.9 repeating. It doesn't work that way. So if we're dealing with a number that has a repeating decimal, most of the time we will use the fraction instead of using the decimal. That, or if it's something like money, we would round it to the appropriate decimal place, which would always be 2. Okay, it asks us to express 2/3 as an equivalent decimal and percent. Then express 2/3 as a decimal rounded to the thousandths place. So when we do this, we want to express it as a decimal. We know that 2/3, 2/3, this bar right here literally means to divide. So that means that I'm going to have 2 divided by 3. And when I do that, that gets me 0.666666. It continues on and on and on. So, what's being repeated here? A lot of you will make the mistake of putting 66 with a repeating bar over it. But that is incorrect. You only put while 66 is being repeated, it's just the 6 itself that's being repeated. So we should write this as 0.6 repeating with the 6 repeating. To write it as a percent, we don't know how to write that decimal 0.6 repeating as a percent. We know that if we had a number like 0.25 and we wanted to write it as a percent, we just move that decimal place over twice. Well, it doesn't work as well whenever we have that repeating decimal. So instead, whenever we change a fraction to a percent, we always multiply by 100%. So I have 2/3 times 100%. Well, we can put this over 1. 2 times 100% is going to give me 200% over 3 times 1. Now when you do this, we can go ahead and set it up with the 200% inside of our division umbrella and our 3 on the outside. 3 doesn't go into 2, but 3 goes into 20. 3 will go into 20 6 times. 6 times 3 is 18. I'm going to subtract. 18 or 20 minus 18 is 2. Bring down that 0. I know that 3 will go into 20 6 times. 6 times 3 is 18. I subtract. I have a 2 left. Okay? Whenever I have that for a percent, I usually want to write it with a fraction. So I'm going to say 0.6 and 2/3. Did I say 0.6? If I did, I didn't mean to. 66 and 2/3%. So this is the proper way to write that as a percent. Okay? And finally, it wants us to write it as a decimal rounded to the thousandths place. So I know that the thousandths place, I have 0 point. We have the tenths, hundredths, thousandths. Okay? So when I fill in with this 0.6 repeating, I'm going to write 6, 6, 6 because that's what goes there. Now I'm wanting to round it to the thousandths place. To round it to the thousandths place, I have to look at the number that's behind it. The number that would be behind it here is another 6. This 6 tells me that I'm going to round up. I have 0.667. Final answer. Express 16 and 2/3% as a reduced fraction and as a decimal. So the first thing it asks us to do is to write it as a reduced fraction. We just talked about on the last slide that to change a fraction to a percent, we multiply by 100. So in this case, we're changing a percent to a fraction. So instead of multiplying by 100, I'm going to divide by 100 because percent means per 100. Remember, cent means 100. There are 100 years in a century. There are 100 cents in a dollar. So I'm going to write this percent over 100. So I have 6, whoops, that's not a 16. I have 16 and 2/3 per cent. Well, this isn't going to last very long because you and I both know that we cannot write a fraction on top of a fraction and it be proper. So what we're going to have to do is we're going to have to rewrite it as 16 and 2/3 divided by 100. Okay? Now when we do this, we have to change this mixed number to an improper fraction to be able to do the math. So remember, when we change to an improper fraction, we take denominator times whole number, and then once we have that answer, we add it to the 2, or to the numerator. So 3 times 16 is going to get us 48, plus 2 gets us 50 over that 3. Okay? So once we get here, we're still dividing by 100. Let me not write that like that. We're dividing by 100. Well, this was a fraction, so we have to turn this into a fraction. Whenever we're dividing by fractions, the first one stays the same. So we changed it to an improper fraction, but it hasn't changed. It has the same value. My division turns to multiplication, and I take the reciprocal. So now I have 50 over 3 times 100th. Now I can do the math. So whenever I do this, I take 50 times 1 is going to give me 50. 3 times 100 gives me 300. I can cancel 0 top and bottom, divide by 5 top and bottom, which is going to get me 1/6. Final answer. Now it wants me to write it as a decimal. Well, that's going to be a lot easier to do now that I have a fraction, because my fraction was 1/6, and we know that when we have a fraction that this bar literally means to divide. So I'm going to take 1 divided by 6. And whenever I punch that into my calculator, I'm going to get, let me see, I don't know off the top of my head. 1 divided by 6, that gets me 0.166666 continues. So I'm going to write that with a repetend. So that means that I'm going to have 0.16, and the only thing repeating here is the 6. So that's what I put my repeating bar over. Not 16. It is not 0.161616. It's 0.16666. So that's how we get that answer. It wants us to arrange these numbers in order from least to greatest. In order to do this, we should always write them in the same form. So to write them in the same form, we are going to, I'm just going to tell you it's easier to change them all to decimals than anything. We have one that is already a decimal. So 4/5, to change that to a decimal, we know that the fraction bar literally means to divide. So I'll take 4 divided by 5, and that's going to get me 0.8. Now on the next one, that is a lot like what we just did with the 16 2/3%. So we're going to write 83 1/3 divided by 100 to change it to that decimal. So we're going to multiply and add. When we do that, we get, oh wait, what am I trying to do here? I'm not, well, okay, we'll go ahead and finish this way. We're going to change it to a fraction and then to a decimal, my bad. Okay, so we have 3 times 83, which gets us 249, plus 1 gets us 250 over 3. We're going to change this to a fraction, so we know my division changes to multiplication, and we take that reciprocal. So when I do this, I have 250 over 300. That will cancel. 25 over 30 will reduce by 5. So that gets me 5 over 6. So I can take that 5 divided by 6, gets me 0.833333, or approximately 0.83 repeating. Okay, so the numbers that I want to arrange from least to greatest now are 0.8, 0.83 repeating, and 0.83. Well, to do this, I'm going to write them out with 3 decimal places. So behind the first one, my 0.8, I'm going to tack on 0, let me do it in a different color. I'm going to tack on 0, 0. Okay, because that's what would be behind there. We don't have to show those zeros, but if we need to, they're there. 0.83 with the 3 repeating, after this 3 is going to be another 3 because it's repeating. Then my 83 hundredths, I know that I can just drop a 0 behind that. So if I ignore the fact that these are decimals, I could say I have 800, 833, and 830, and I want to write those from least to greatest. The smallest number there would be my 800. So that's going to be my first one. My next one would be 830. And finally, my 833. When I write them in order, though, remember we have to put them back in their original form. So the 800 was the 0.8, which was 4 over 5. Then we have that 0.83. And finally, 83 1/3%. The incumbent received 41 2/3% of the, oh, I've got myself wrapped around the cord here. Okay. 41 2/3% of the 1,260 votes cast in the town council election. Describe how to estimate the number of votes the incumbent received. Then calculate the exact number of votes. So first they want us to do an estimate. Okay, we want to estimate. Well, instead of saying 41 and 2/3%, we could say that that's pretty close to what percent? We'll say 40%. And if he got 40% of means to multiply the 100, or not 100, 1,260 votes. So that 40% I could change to a decimal by moving it over twice. So I can say 0.4 times that 1260. And when I do that, I get around, okay, 504 votes, which comes out exactly to 504, but we're estimating. So we're going to say it's around 504. Instead of saying 504, we could say it's approximately 500. This is our estimate. Now that I say that, do you think the estimate is going to be above or below the actual number? I hope that you chose below, because we went down from that original percent. So now we need to find the actual number of votes that the incumbent received. And to do that, we're going to have to change that 41 and 2/3% to a fraction. Because remember, when we have 2/3, that's going to be repeating decimal. We can't change that to a nice easy decimal. So we're going to have to take that 41 and 2/3, and we're going to be dividing it by 100. So we remember that we multiply and add. So we take 3 times 41, and that gets us 123, plus 2 gets us 125 over 3. Change this to a fraction so that I can work through the problem here. Division turns to multiplication, and then I take the reciprocal. So I have 1 over 100. Now 125 times 1 is going to get me 125. 3 times 100 is 300. So 125 divided by, or over 300, is going to reduce. Okay, we can reduce it by 25. Top and bottom, we'll start there. Divided by 25. So 125 divided by 25 is going to get us 5 in the numerator. Over 300 divided by 25 gets us 12 in the denominator. So this isn't going to reduce any farther. Now that I have this number, I can still say that the incumbent received 5/12 of, means to multiply, the 1,260 votes, which I can make a fraction by putting it over 1. So 5 times 1,260 gives us 6,300 over 12, because 1 times 12 is 12. So when we take 6,300 divided by 12, that will get us 525 votes. Final answer. Recall that negative exponents indicate the reciprocal of the positive power of a base. We talked about this just the other day. To change that negative exponent to a positive, we can put it over 1. Whatever that negative exponent belongs to, we move it across that fraction bar. So whenever we do that, we're left with a 1 on top, x to the positive n on the bottom. It works just the same if we're using numbers instead. So I put it over 1, take that negative exponent, move it across the fraction bar, leaves me with 1 on top and 3 to the positive 2 on the bottom. Also recall, with fractions, we reverse the position of the numerator and denominator to form the reciprocal. We just talked about that whenever we were changing those percents to fractions. So the reciprocal of x over y is y over x. We just switched the places. These two things traded places. If the base of a negative exponent is a fraction, we make the exponent positive by replacing the fraction with its reciprocal. So in this case, instead of moving anything over the fraction bar, we just say it belongs to this whole thing. So we're going to take the reciprocal of the whole thing to then make it a positive. Alright? So for example, it wants us to simplify. In order to make this -2 a positive, I'm just going to take the reciprocal of what's inside those parentheses. So instead of 1/3, I'm going to end up with 3/1. And instead of a negative, it'll change to a positive. This is the same as saying 3 to the second power, which we all know is 9. Okay? Your homework for today is lesson 63, A through K, and 1 through 25 odd. It will be due tomorrow whenever you walk in the room. Make sure that you are working quietly and individually at all times. If you have any questions, I'm sure that you'll be able to receive some help. Be good, no talking. Make sure the assignment gets put on the assignment board, please.